Hello students, Similarity video number 7. Now we are going to learn very important theorem in similarity. Yes, and the theorem is basic proportionality theorem. See the statement of the theorem. Listen carefully, concentrate how I am reading. Okay, if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Okay, simply by reading we do not understand anything, so pay attention. Again I am reading the statement of the theorem. If a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. So see the figure. Line L is parallel to side BC of a triangle ABC. Line L intersects side AB in point P and side AC in point Q. Is then is this line L divides the side AB and side AC in the same proportion, that is AP upon PB is equals to AQ upon QC. Yes, listen again. Line L parallel to side BC of triangle ABC. Line L intersect the side AB in point P and side AC in point Q. Then the line L divides the side AB and AC in the same proportion, that is AP upon PB is equals to AQ upon QC. Students, you should understand what the statement is. So you have to read it aloud 5 times so that you will understand the meaning. And now we'll see what is given, what to prove, and the construction required. Given in triangle ABC, line L parallel to line BC. And line L intersects AB and AC in point P and Q respectively. This is given to us. What to prove? To prove AP upon PB is equals to AQ upon QC. That is, line L divides the side AB and AC in the same proportion. To prove this result, we need the construction. What is construction? Draw segment PC and segment BQ. So I'll draw here segment PC, segment BQ. So construction, draw segment PC and segment BQ. Okay, we'll go for the proof. See here, triangle APQ. This triangle, triangle PQB. This triangle, these two triangles have common vertex Q and their bases AP and PB lie on the same line. So these two triangles are of equal heights. So triangle APQ and triangle PQB have equal heights. Therefore, area of triangle APQ upon area of triangle PQB is equals to AP upon PB. This is result number 1. Okay. Now see here, triangles are of equal heights. So ratio of the areas of these two triangles is equals to a ratio of their corresponding bases. Is reason for these areas proportional to bases. Also see here, triangle APQ and triangle PQC. These two triangles have common vertex P and their bases AQ and QC lie on the same line. So these two triangles are also of equal heights. Triangle APQ and triangle PQC are also of equal heights. Therefore, area of triangle APQ upon area of triangle PQC is equals to AQ upon QC. This is result number 2. Reason, areas proportionate to bases. Now see here, for the triangle PQB and PQC, PQ is the common base. That is, these two triangles are of equal basis. Also, PQ is parallel to BC. That is, line L is parallel to line BC. It means triangle PQB and triangle PQC lie between these two parallel lines. So, these two triangles are of equal heights. Hence, triangle PQB and triangle PQC are of equal bases and equal heights. So, the triangles are equiareal. That is, their areas are equal. So, right here, segment PQ is common base of triangle PQB and triangle PQC. Segment PQ parallel to segment BC. Hence, triangle PQB and triangle PQC have equal heights. Therefore, area of triangle PQB is equals to area of triangle PQC. This is result number 3. Now, see the result number 1, 2 and 3. In result number 1 and 2, these numerators are equal. From the result number 3, these denominators are equal. So therefore, this ratio is equals to this ratio from 1, 2 and 3. Okay. So what we get the result? Area of triangle APQ upon area of triangle PQB is equals to area of triangle APQ upon area of triangle PQC. This is from 1, 2 and 3. So, but this is equals to AP upon PB and this ratio is equals to AQ upon QC. And therefore, what we get? AP upon PB is equals to AQ upon QC. This is from 1 and 2. And this is the result that we have to prove. Okay. So, students, this is very important theorem in the similarity. Is learn it carefully so that you will get it understood and you have to or we have to apply the statement of the theorem in solving the problems. Now we will go to converse of basic proportionality theorem. What is the statement of the theorem? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Again I am reading. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So, in the figure, line L intersects the side AB and AC in 2 points P and Q. And we have the result AP upon PB is equals to AQ upon QC. That is, line L divides the two sides in the same ratio. Then what is the result? This line L is parallel to the side BC. This is converse of the basic proportionality theorem. So see here, in the figure, line L intersects side AB and side AC of triangle ABC in the points P and Q. Respectively, and AP upon PB is equals to AQ upon QC. This we are having is, hence if we have this result, then what? Then line L is parallel to segment BC. So this is converse of the basic proportionality theorem, and there is no proof. Just we have to learn the statement. So see here is, what is converse? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. In the figure, line L intersects side AB and side AC in points P and Q respectively, and AP upon PB is equals to AQ upon QC. Is, what does it mean? The line L divides the side AB and AC in the same proportion. If it is so, then the line L is parallel to segment BC. Students, learn the theorem of basic proportionality theorem and its converse carefully, get it understood so that we will apply the statements in solving the problems.